is the Ishwar Rao. I did from JNT and doing okay. And we'll be teaching me and Mohan Krishna. Okay, he is also one of the senior faculty in Vignan Institute. Okay, his name is V. Mohan Krishna. Okay, he is also one of the senior faculty in Vignan groups. Okay, even in WITS also. Okay, we'll be teaching this engineering graphics for this whole year. And another faculty, Rajiv Kumar is also there. Okay, he is also will be assisting you in engineering graphics. Okay, the third faculty. We three will be handling this engineering graphics. Okay. Okay. So what is graphics? Before going to graphics, all of you know that drawing, right? What is drawing? Can anyone answer me? What is the drawing?
Drawing is an art.
Art. Okay. Anything?
A picture or diagram.
Diagram.
It's a form of depositing anything, sir.
Huh? Hello?
It's a visual art.
Visual art. That comes under art.
It is something to represent our talent. It represents something easily.
Drawing to express something.
Okay. Right. So we'll see.
Blueprint.
Okay. All other things will come under drawing itself. Okay. Whereas coming to this, what is the drawing means? It is the representation of any object. Isn't it or not? This is the representation. The representation of object. Okay. So whereas coming to this drawing and engineering drawing or engineering drawing, what is the difference? Drawing is a form of anything, okay, which can be derived in anything, okay. Whatever you see in the real world, okay, that can be described in a graphical manner or the drawing manner, okay, on a paper is called the drawing, okay. Whereas coming to engineering graphics, this engineering graphics is different from general drawing. Why? In general drawing, if you want to draw a line, okay, you can draw like this also. This is also a line. Whereas coming to engineering graphics, okay, a line means it's a straight line. Line means it's a straight line. Okay. And whereas coming to drawing, if you want to draw a curve, okay, without any references, you can draw a curve. Okay. Whereas coming to engineering graphics, okay, whereas coming to engineering graphics, you have to take a center point, and from there, as the reference, you need to draw the curve. Is that clear? Okay. This is the radius. Okay. This must be considered in engineering graphics. Okay. Okay. Now, so what is meant by drawing?
It would be representation of
Representation of an object.
hello.
Mute yourself. The drawing means it's a graphical representation. Before going to graphics, what we call this session, it is a bridge course between the intermediate and engineering. Okay. How this drawing is interfered with this bridge course. Okay. How this is important for us to learn. Okay. Now I'll give some information before going to this. Okay. See, in engineering, we'll be having number of branches. Like you can see, PCE, and subjects with CSE like AML and okay, data science and other things, right? And whereas coming to core subjects, mechanical, civil, okay, and some other subjects will also be there. Okay. Now see, only the mechanical and civil will learn this engineering graphics for the whole 4 years with different names. Okay, because mechanicals will be having different subjects like engineering drawing, machine drawing, power drawing, and some other drawings. Okay, whereas civil also will be having the same subject, okay, in different manners, right? And why we are studying this engineering drawing or engineering graphics? Okay, this is the general language of all. Keep it general language. Language of all engineers. So keep it in mind. This is the general language of all engineers. How? Because an ACE person will be having some circuit diagrams or some other things, okay, and all other things, okay. In the same way, the CSC will be having the same drawings, right? And CSC and IT will be almost the same, right? And in the same way, mechanical will be having different of machine parts or everything, okay. And civil will be having their construction values, okay. And triple they also will be having different types of circuits and connections and different things, right? When a person want to study something, okay, see, whereas coming to uh, let's say this is a diode. Generally, we call that as a diode, right? And this is a capacitor, right? They are connected to each other, right? If it is a parallel connection means it will be like this, isn't it or not? If it is a parallel connection, it will be like this. Otherwise,
Then what about CSM, sir?
uh, here I'm giving the general representation how the graphics will be used. Okay, I'm just giving only the difference. Okay, for EC and AAA, this is how they will be using. For CSC, you will be having the flow charts and all other things, isn't it or not? Okay, there also you will be having different types of representations. Okay, for start and stop. Okay, for execution and for some types of loops. Okay, these types of representation you will be considering in CSC, right? For that also, this engineering drawing is very much important to learn. Is it clear? Okay, now you might have understood, okay, how this engineering graphics is useful to each and everyone who is studying engineering, right? That's why we call this as a general language of all engineers. Is it clear? And whereas coming to mechanical and civil, they will be having their own different types of drawings and all other things. Okay, for that also, see, you may understand or you may not understand someone's literature in the textbook. Okay, in intermediate also, you'll be having different types of textbooks for physics or chemistry or whatever it is. Okay, some particular author will give the easiest language how a student can learn the subject, isn't it or not? Okay, there will be different types of publishers and different types of authors also will be there. Okay, and some particular author with the particular author or particular publication, the subject and that explained is very easy. And in some subjects, in some different authors or publications, it is the subject or the literature will be somewhat complicated. You might not understand. It takes some time. Whereas coming to drawing, by seeing the drawing itself, you can easily say that, yeah, I can understand this, what the author is saying, isn't it or not? How the connection is there, right? You might have seen some drawings also, like while connecting a mobile phone or with the speaker. Okay, there some drawings will be given when you bought a new phone. Okay, in a manual, right? All the circuits will be given how to connect and where to connect, isn't it or not? Which type of pin and where to connect, right? And what is the purpose? All those things will be given in the manual the same way. That means if you want to read all the manual and understand, okay, without doing that also, by seeing the graphical representation, you can understand the procedure, what and how we can do, isn't it or not? That is why this engineering drawing is very much important. Is it clear? Okay. It is saying that if compared with verbal and written description, drawings offer far better idea about the shape, size, and appearance of any object at any situation. Okay, a location, that too in quite a less time. See, by reading this, you can understand that. Okay, what I have explained till far, isn't it or not? Right. So it is that's why we are calling this is the general language of all engineers. But here we consider it as it is for engineering only. Okay. See, we have discussed itself. The drawings are two types. Okay. The first one is freehand drawing, and the second one is constraint drawing. So freehand drawing means, what is it? If you want to draw a house, right? How a kid draws. This is how a kid draws a house, isn't it or not? And this will be door and this will be some window. Like that he will draw. And there will be no dimensions or the shapes or whatever it is. Okay? He draws it free-handedly. That means though no lengths are mentioned and no specific dimensions or the angles are mentioned here. Okay? Just he has drawn a house or the hut. Okay? Now see here. That's coming to this. This is called the freehand drawing. Whereas coming to constrained drawing. See how a house can be constructed. See, a house is having a 4-meter width and a 4-meter length. See, this is a 4-meter width, and in the same way, I'm taking another 4-meter length. Okay, and the same way, it is having a 5-meter height. Right? Now, I'm completing this. See, if you can see, the angle between these two is 90 degrees. Right? The constraint. The lines are constrained or not. You can see. See, here also the angle is 90 degrees. These two lines are constrained with each other. And these two lines also constrained with each other. And there is some other angle will be given for these two and these two. Is that clear? Okay, that's why we call this as a constrained drawing. Now, you have the difference between freehand drawing and the constrained drawing. Okay. See here, whereas coming to freehand drawing. Previously, I told that without any specifications or the angles or whatever it is. Okay, we can draw something like this. Or else, if you want to draw a flower, okay, like this, right? This is how you draw a flower. And with the pot, this is a freehand drawing. Whereas coming to constraint drawing, okay, can we draw a flower like this? No, because this will be drawn with the freehand drawing itself. We can't draw the flower and the pot with the constraint drawing. But we can draw the pot with the constraint drawing. See, if I mention the pot, see, I'll be having from 10 centimeter of base, and with some 10 degrees inclination, I'll be having the pot, right, the side inclinations, and say only from the front. And if I want to see it in 3D, see, it will be like this. Isn't it or not? You can draw the pot like this. This is a freehand drawing. Whereas coming to engineering drawing, this is a view, one of the view, how it can be visible from one side. Okay. Now you have the difference between freehand drawing and the constraint drawing. How to understand and how to draw. Okay. Now we'll see what are the differences between the freehand drawing Now tell me, how many types of different drawings are there? Now you tell me. I told you
Two
that
types. Two types.
just
Two
note
types.
that.
Two
Just
types.
note that. In freehand drawing also, we will be having different and in constraint drawing also, we'll be having different types of drawing. Allow any one type. What do you know? In general.
3D drawing.
Geometric diagram drawing.
Pencil drawing.
3D.
Graph.
Huh?
3D drawing, sir.
Graph, sir.
Graph.
Geometric diagram.
Geometry. Okay.
Symmetric drawing.
Symmetric. Okay. And
Life drawing.
nice. Isn't it? Okay. Any other?
Architecture and fashion designing.
Fashion designing, right?
Perspective drawing.
Architectural drawings.
Architecture.
Pencil drawing.
Architecture drawings.
Artificial black and white. Black and white sketch.
Pardon?
Analytic drawing.
Analytics.
Black and white sketch.
Black and white.
Yes, sir.
Okay. Next. Any other?
Perspective.
Shading. drawing.
Perspective reading. Any other? Huh?
2D drawing.
See.
2D.
Any other? Now, here we are having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, almost all 10 different types of drawings are there.
Sir, illustration drawing.
Illustration. Okay. Right. Right. See, here we are having 11 numbers. Okay. Can you differentiate these between the freehand drawing and the constraint drawing?
Some we
Yes,
can, some
sir.
we can't. Yes, sir.
3D, 2D graph, 3D, 2D graph, geometry, symmetric are constraint drawings, sir.
Constraint
Fashion
drawing.
design,
Fashion
architecture are freehand drawings.
freehand drawing.
Sir, architecture drawings are also
Architecture also constraint drawing.
Some
Architecture
freehand
drawing.
Okay.
some
But we
architecture
can't say that.
some architecture drawings are freehand drawings, some are constraint drawings, sir.
See, now I'll give you the difference. See here, what is natural drawing? See, one of the parts is natural drawing. Okay, one of the type is natural drawing. See, natural drawing means here it is been given landscape or a scenery. Isn't it or not? If you want to draw a scenery like a hill, sun, okay, and all other things, and lakes, right, on the water flowing from the hill station to the lower part, okay, and all other things, right? These are called the natural drawings, the sceneries or the landscapes or whatever it is, right? Let's see, the second one is geographical drawings. See, these types of drawings cannot be scaled. See, you can see the maps or the Google Maps in your Android phone, isn't it or not? You cannot scale them, right? And the shape or the differences, you cannot exactly say that this is how the drawing will be, right? The geographical, or else if someone or some other relative gives you the address, right? How you draw? See, you don't know. You have went to some other place, and your relative or some other person have given the address like this. After getting down at the railway station, okay, you have to move 100 meters on the main road, and there you have to take a right, right, and you just draw a length and you write down that it's 100 meters, isn't it or not? And after that, taking the right, okay, you have to move 2 lanes, and to the third left, you have to turn and you have to move, and there a temple will be at the left, right? Exactly beside that, you will be having a lane. You have to enter into that lane, right? This is how the representation will be given. This is called the geographical representation, right? That means whatever you draw, right, is called the geographical representation. And botanical drawings. Now, previously we have told that the plants or the flowers or whatever it is, okay, they are all come under the botanical drawings. These are all called the freehand drawings, okay. And zoological drawings, that means if you want to draw an animal, how? Animal. Tell some animals. You know any of the animal?
Yes.
Can you name any one thing?
Frog.
Okay.
Lion. Elephant.
Cockroach.
Tiger. Camel.
Tiger.
Elephant.
Yeah,
Giraffe.
yeah.
Giraffe.
You know all
Tiger.
that. Okay. The wild animals and the pets. Okay. Now I understand that. Now see here how a dog can be represented. This is how a dog can be, isn't it or not? And that will be exact health and all other things. And the portrait. See, portrait. What is a portrait? It is the face
Pictures.
or the expression of a person. Okay, right? Or a or an animal, whatever it is. Okay, okay. Any animal, right? That is called a portrait. Say, we can call them as the Picasso or whatever it is. Okay, we'll be having all those things, no? Okay, the drawings, they are all freehand drawings. Okay, see, now the natural drawing, geographical, botanical, zoological, and portrait, all these things are freehand drawings. These are the different types of freehand drawing, and you don't know. In freehand drawing also, we'll be having these types, right? So you see here in engineering drawing how it will be, right? Engineering drawing means projection. See here, building related drawings and machine component drawing. See, building related means it's a civil related, and machine component related means mechanical. See, and here these two are not different from the constraint drawing. Okay, these two are not different from the constraint drawing. Now see here, and how many types in these two also will be. See, in buildings or machine component drawing, see how many types are there. The orthographic projection and projection. These are the two different types. What is orthographic and what is isometric? Okay, see here, it is given that FV, TV, SV. What are all these? television means we different things, and the same terminology in civil engineering we call them as the plan and the elevation. Okay, the plan means top view and the elevation means front view. Okay, this is the different types we call them in different trades. Okay, and these are the working drawings for 2D type. Okay, how this is related with our subject. Okay, now see here, the orthographic projection is nothing but how we see an object from the front. See, if you want to see a person from the front, or else you will be having, let's say, okay, you might have seen some of the stories in Facebook also, right? How an elephant is visible from the front. This is how they draw. Isn't it or not? You might have seen and you might have made some of the jokes, right? This is how an elephant can be visible from the front. And whereas coming to the side view, how it is visible, right? This is how it can be visible from the side. Okay, see here, I'm just giving the representation, not exact length, right? I'm just giving some representation, how it can be visible from the front and how it can be visible from the side. This is the representation. Okay, right? Now you got the point. Can you understand this? Can you understand this?
Yes, sir. Yes, sir.
Yes, sir.
Orthographic projection. Okay. Just be silent. Right. Okay, this is called an orthographic projection. Whereas coming to isometric, what is isometric? In orthographic, we have seen how an object or a person, okay, whatever it is, the object can be visible from the front, side, and the top, right? That is represented in orthographic projection. Whereas coming to isometric, how an object can be visible in a three-dimensional way. Okay, how an object is visible in three-dimensional way. Here also different types. Isometric name is the name which is used by mechanical engineering. Okay, and the perspective projection is used by the civil engineers. Okay, actually, perspective projection is the exact view how we can get. That is used by the civil engineers. But whereas coming to the isometric, okay, how considering all the sides are equal and all the visibility is equal in length, whatever may be the length or whatever it is. Okay, we'll consider that in isometric way. Let's say, consider a stool. Consider a stool. How it will be. This is how the stool will be, right? Is it clear? This is the stool. Okay. Now, whereas coming to isometric drawing, okay, considering, see here, we'll be having different lengths here. From here to here, and from here to here. Okay, the length will be equal at the bottom, right? You can see your stool anywhere, right? Either it may be at your house or somewhere. You might have seen the stools. Okay, see the bottom, these four legs length from here to here and from here to here, from here to here and here to here. That means from each adjacent leg, okay, those edges length, the distance between those two edges bottom length will be equal, as well as this length, okay, the top part plate length, okay, that will be a square part, okay, that will be mentioned here, okay, and see here this length. Whereas coming to isometric drawing, these lengths will be equal. Whereas coming to isometric, these lengths will be equal. When coming to perspective, this is the initially visible part. That's why these lengths will be. Don't disturb the class. Mute yourself. Okay. See, in isometric drawing, this length will be equal with this, okay, and this length will be equal with this. That's coming to perspective view. These are the edges which can be visible initially, and these are the edges which are behind that. That means the length will be minimized. Okay, that is how a perspective drawing will be.
Excuse me, sir.
Chepparama.
Sir, actually, I just had a power cut, sir, so I couldn't listen to the topic properly. So, once can you please revise all those? Because due to power cut, I was offline. Again, I connected, sir.
How much
Please.
time you have been away from the class?
Some 15 minutes, sir.
Okay.
Mm.
For 15 minutes, if I continue the class, like, okay, then you can have the video. Okay.
Okay, sir.
You can have the video. It will be posted in the group. Okay. You can listen there. Right.
Okay. Okay, sir.
Every point what I have explained here, you can listen there. Right.
Okay, sir.
Thank you, sir.
So generally, what drawing, which is a 2D or 3D views of an object without the purpose of manufacturing. It is done manually or without the aid of a computer. The computer law, okay, will say if the same thing is done in a computer, okay, what do we call that? All of you might have seen this special movie. Have you seen or not? Okay, don't reply me. Just keep it in mind. Okay, there's Bahubali. Have you seen it or not? Okay. In Bahubali, all the things are graphics. Right? That means virtually they can visible as a three-dimensional. They are all graphics, but actually they are not existing there. The actual part is not existing there, but they can be visible in that way or in that manner. That is called the graphics. When we do that in the computer, okay, that is called the graphics. Whereas the same represented on a paper by using engineering graphics is called a drawing. Is it clear? It's called a engineering drawing.
Sir,
Right?
didn't get you, sir.
Huh?
Could you say it once again? I didn't understand.
This one?
Yes, sir.
Okay, I'll explain. See, I'll explain from here. Whatever you see in Bahubali are called the graphics. Isn't it or not? These are all prepared in a computer. Right? Actually, they are not existing, but they look like they are existing there. That's why we call them as the graphics. The same graphic, okay, the same view is projected on a paper, right? You might have seen some of the videos in YouTube also, okay, how the projection of the Mahal will be and how the heroine will look like and all those things they have drawn on some paper, okay. The director will be holding and some other persons will be costumists also will be holding those papers. That means how we have to elevate a heroine or a Mahal or whatever it is, isn't it or not? Okay, the same thing will be represented on a paper. This is the movie view. When you see the movie, okay, it is represented in graphics. Okay, before going to elevate this graphics, they have to produce a pictorial presentation on a sheet. Okay, that is called the drawing. Is it clear? Now you have the difference between graphic and drawing. Is it clear? Right?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Just be silent. Mute yourself. Okay. Now see here. So this is called the drawing. When you project a pictorial presentation on a sheet is called the drawing. When you project the same pictorial presentation in real life, it's called the graphics. Okay. This is the difference between a drawing and the graphics. And why do we call our subject or the engineering graphics? Because we produce these graphics on a sheet, on our drawing sheet. That's why we call that as the engineering graphics. And here, these things, the lens will be unmentioned. Okay, the lens will not be mentioned. Whereas coming to engineering graphics, will mention each and every minute lens perfectly and do the drawing. That's why we call this as the engineering graphics. Is that clear? Okay.
Sir, can you repeat once again?
What should I repeat?
Last point, sir.
Last point. Okay. When we represent the graphics on a sheet, okay, when we represent the visual graphics on a sheet, representation of visible graphics on a sheet is called engineering graphics. So visual means only the machine part. Only the machine parts or else the constructional part. Okay, na? The visual graphics, what we discuss here in engineering drawing is the visual graphics which are produced on a sheet is called the engineering graphics. What we produce here are machine parts or the constructional parts. That's it.
Okay, sir.
Right? Now previously from intermediate, from childhood also, you have seen the different types of drawings as we discussed the freehand drawing, isn't it or not? Right? Those different types of freehand drawings you might have known. Okay, only in the mathematics or some other places you will be having the geometrical and all other things, isn't it or not? Okay, that geometrical drawing, okay, is now used here. Screen sharing obligation. Okay. But share it, last slide, I think.
Sir,
Ah,
So class completed, ah?
yeah, in 2 minutes we'll wind up.
ఎందుకమ్మా ఏమన్నా పని ఉందా?
sir,
No, sir.
tomorrow again. Sir,
Yes.
will this class continue tomorrow again?
No, no, no. This is the end of this session.
Sir, is there any another class after this class?
Yeah, there is another class.
Again at which time, sir?
Timing. Continuation, sir.
No. With a minimum gap of 15 minutes.
Next class will start, sir.
Timing, sir.
Timing after the end of this session, 15 minutes, and after that we'll start another class.
So can we end up the call now?
Okay. This is the last point. I'm going to discuss about this class. Okay, the engineering drawing. I'm winding up. Just give me 2 minutes, right? Okay. So in engineering drawing, we'll be having 2D and 3D views. Okay. Only the 2D means the orthographic projection, and the 3D means the isometric projection. Only these things we'll discuss and we'll study about engineering drawing here. Okay, in first year. That's it. Right? This is the end of the session. Right? Okay. Only the engineering drawing session ends here. Okay? Thank you.
Okay, sir. Sir, again at what time class will be started, sir?
After 10 minutes, okay?
Okay, sir. Now can I end up the call?
Sir, will you leave
Sir,
this like
Okay, you
this,
can.
sir?
Why?
To note
We can
same
start.
link or another
Same
link you
link.
sent, sir?
Yes, same link we have to continue.
We have joined the same link or okay, sir.
Same link. Okay, the same link will be set there.
Bye, sir.
Thank you, sir.
ఇక్కడ స్టేజ్
Thank you,
కూడా స్టే
thank you,
చేస్తాం
sir.
కదా మళ్ళీ ఎండ్ చేసేసి మళ్ళీ ఒక 10 minutes కనెక్ట్ అవ్వచ్చు
Sir, thank you.
Yes, sir.
Then the
Thank you, sir.
Thanks, sir.
Thank you, sir.
Thank you, sir.
Sir, we'll get the link of the another session.
సేమ్ లింక్ ఓకే
Okay, sir.
వీడియో ఆన్ చేసారు వర్క్ చేయాలంట మేము ఏం చేస్తుంది ఇప్పుడు సంకల్ప అంటే వేరే క్యాంపస్ లేకపోతే మన దాంట్లో ఉంటుంది అది నైన్త్ లో అయిపోయి చేశాను అంటే ఇంకా నైన్త్ లో ఐఐటి చెప్పలేదు కాదునా నైన్త్ లోను 10th లోను